2024 revision series for the subject production. For the production subject, you know it is very big subject. Therefore, we are coming with the 2 videos, 2 session. This is the production 1 session, and there will be production 2 second session will be there. Now you can see that in the revision series, guys, I am taking some important question, and through that question I am going to explain the theory behind that question, and that question is very, very important for your SSC JE 2024 exam. I want to give my introduction first, guys. Already I given my name is Ravi. I completed Mech in 2013 from the subject manufacturing, and it is good for me. I am teaching the manufacturing subject here. Then I am very, very happy. Now just see the syllabus of SSC exam first. Now see that this is the syllabus of total production subject, and the total syllabus we converted into the 8 chapters. You can see out of that 8 chapter, you can see the casting, welding is very important. These chapters are very important chapters. Casting is very important, welding is also very important, then metal cutting is very important, and machining is also very important. Till now, out of that 8 chapter, on the 4th chapter there are very good questions in your SSC JE prelim exam, but in the syllabus you can see the total 8 chapters. Out of that 8 chapter, today I am going to focus on first chapter in the production 1 video, production 1 lecture. You can see the production 1, I am covering this 4 chapter. And in the production session 2, we will see the questions and concept of the remaining 4 chapter. Now I want to start with very important chapter, the casting, and in that chapter casting you will learn the many concept. Now see here the first question. Guys, the cheap advantage of die casting. Guys, why I come with this question? You can see this is the SSC JE 2007 question, but the die casting is very important. And for the die casting, some student has confusion about the die casting. Guys, the main advantage of die casting is the high production rate. High production rate is the main advantage of this die casting method. After the 2007 also, in the many important exam, many PSU exam, that this question is going to repeat, the cheap advantage of die casting, or out of following method, which method has highest production rate. If you learn the investment casting, then you know that in the investment casting, in one mold we can get the 5, 10, 20, 30, 50, 100 of components, and therefore the student think that the investment casting has high production rate, but it is not true. In the die casting, we are using the metal die, and by using metal die we can produce the infinite number of components. But in the investment casting, if you are going to make one die, then by using that die you can make the 5 components, 10 components, 20 components you can make. Okay, then to make that mold, not a die, the mold. In one mold you can get the 5 components, 10, 20, 30, 50, 100 of components, but to make the mold some time is required. To make the mold, one die is required. From the die we need to make the pattern, from the pattern we need to make the mold, and that is the total time consuming process is the investment casting. But in the die casting already we have one metal die, and through that metal die we can produce the infinite number of components. Hence, when there is a question about the die casting, the student has confusion between the investment casting and the die casting. And here you can see the correct answer is high production rate is possible. Possibility of incorporating thick section in small casting, casting of inserts is possible, wide tolerance are possible. The correct answer is what? High production rate is possible, the chief advantage of die casting. In a such way that I come with very important question, confusing question, and I am going to clear the concept here. Second, uniform sand hardness uniform sand hardness is obtained throughout the mold by which of the following molding machines? Guys, here I want to draw one diagram. Here one ground is there, and on that ground I am putting one beautiful pattern. That pattern may be of wood, that pattern may be of metal, that pattern may be of wood, that pattern may be of metal, or that pattern may be the plastic pattern. And on that pattern we are throwing, the sand. Here on that pattern we are going to throw the sand continuously. And guys, in the sand slinging method, or here you can see the sand slinger, by using sand slinger we are going to throw that sand with some force. Means by using that sand slinger or sand slinging machine also we can say, by using that sand slinging machine we are sending the sand with the force on the pattern. Just see, if it is the cubical pattern is there, this pattern is cubical, then on the 4 vertical sides and one top face, means total on the 6 faces, we are sending the sand continuously, and you can observe that the uniform ramming is there. Uniform ramming. Ramming means localized compression is there everywhere, the localized compression is there everywhere. As we are throwing the sand with the force, the localized compression is there, and we can get the uniform strength as well as uniform hardness. Now here you can see that uniform sand hardness is obtained throughout the mold by which the following molding machine. The correct answer is sand slinger. But guys, in some references you can also see the answer diaphragm molding. That is not exact answer. The exact answer is sand slinger. If the sand slinger is not available in the option, then you can go with the diaphragm molding. Okay. Now see next question. The taper provided on pattern. Guys, the taper provided on pattern, you can see that there are number of allowances are there. Shrinkage allowance, machining allowance, draft allowance, shake allowance, distortion allowance. The number of allowances are there, and here the taper provided on pattern for its easy and clean withdrawal from the mold is called as. The same question they also asked in GATE 2024 also. This all important question. The same question is repeated for the GATE. GATE theory question will repeat for SSC JE exam. The all previous exam questions in the India is important for your SSC exam. Now guys, the taper is provided. Just see, I am drawing here one pattern is here. But on the pattern, if we are providing some taper, means we are manufacturing this type of pattern with some taper, and that is known as draft allowance. And here you can see that that angle is what? That angle is draft angle. Guys, why I come with this question? This question is not tough, very easy, and you know that the draft allowance is correct answer. But guys, there is a mistake in option here. The draft allowance is also known as taper allowance, because here you can see that we are going to provide the taper on the pattern. Hence, the draft allowance is also known as taper allowance. Then both A and B is correct answer. Distortion allowance is not correct, and pattern allowance means what? For the pattern, the number of allowances are there. The total 5 types of allowances are there. Hence, the correct answer A as well as B. Some references, some books, some solution, you will get the answer only draft allowance. But guys, the draft allowance is also known as taper allowance. Hence, the correct answer is option A as well as option B. Next, surface to be machined or marked on the pattern by the following color. Rarely asked question, they never asked in GATE exam, but SSC you can see once they ask that question. The surface to be machined or marked on the pattern by following color. If I hope so you learn the casting very well, your concepts are clear. Guys, what the shape of pattern? The shape of pattern remains same as the shape of casting. Okay. Then guys, firstly we are making the pattern, and on the pattern we are giving some color. On the pattern, if we are giving some color, okay, then if the surface to be machined, then we are giving red color on the pattern. Red color on the pattern. And for unmachined surface, to denote the unmachined surface, we can give black. Black color, we can give the black color on unmachined surface. They can ask about the unmachined surface also, but on the machined surface, we are giving the red color. Next, in order to facilitate the withdrawal of pattern, okay. In order to facilitate the withdrawal of pattern means to remove the pattern, what is required? Pattern is made smooth? No. Water is applied on pattern surface? Wrong. Allowances are made on pattern, this is the correct, and draft is provided on pattern, this is more correct. Yes, correct answer is option D, draft is provided on pattern. Means if you want the cubical casting, just see I want the casting of this size, but then I am making the pattern of this size. Then here the draft I am going to provide, means some angle I am going to provide on the pattern, and that is known as draft angle or draft allowance, or also we can say as taper. Which of the following is not a casting defect? Guys, you can see the hot tear is very famous casting defect, the blowhole is also very famous casting defect, the scab is also very famous casting defect, and here is the decarburization, it is not a casting defect. Now guys, what is mean by decarburization? What is mean by decarburization? Guys, the decarburization means we need to remove the carbon from that workpiece. We need to take out the carbon from the workpiece is known as decarburization. Then to remove the carbon from the workpiece, it is not a casting method. Okay, it is not a defect in casting. Then which of the following is not a casting defect? The hot tear, blowhole and scab are the casting defects are there. Next, shrinkage allowance is made by. Guys, this is somewhat difficult question to answer. The shrinkage allowance is made by. Guys, you know that firstly we are making one pattern. By using pattern we are making one cavity, we are making one mold. Then we are removing the pattern. Then in that mold or cavity we are pouring the molten metal. And as the molten metal is converting into the solid, then what happens? The shrinkage is going to happen. The shrinkage is going to happen means the size of that component is going to reduce, means whatever the cavity size, if consider the cavity is cubical, then if the cavity size is 10 centimeter, then the component size will be the lesser than 9 centimeter or 9.1, 9.2, any size. If we are doing the cubical casting, then guys 10 to 9 centimeter means there is shrinkage of 1 centimeter, then that is known as shrinkage. And because of that, what we have to do, we have one formula, pattern size is equal to pattern size is equal to casting size plus allowances. This is general formula, but sometime also we are using the minus also. Now guys, the shrinkage allowance is made by, this is important question, how the shrinkage allowance we can made by adding to external and internal dimension, subtracting from external and internal dimension, subtracting from external and adding to internal. From that all option I understood one thing, we have the component that is hollow component we have. It may be the disc-like component or any shape of component, means that component may be of disc type component or maybe one of the square component, but it is hollow component, okay, hollow component, okay. Then guys, I come with this example. Now to understand this is not easy, somewhat difficult to understand, but here you can see that I am showing here, this is one of the pattern, this is one of the pattern. We made one pattern, and by using that pattern we made one mold, and from that mold we removed that pattern, and now we are pouring the molten metal. Guys, when we are pouring the molten metal, then what happened? The shrinkage is going to happen. What? The shrinkage is going to happen. Just consider that the number of molecules are available. The number of molecules are available. Number of molecules are available. Number of molecules are available. Okay, number of molecules are available. Yes, you can see I am showing here the number of molecules. Guys, what happen when the shrinkage is going to happen, then the distance between the number of molecule is going to reduce. Just take the example here. Distance between two gas molecule is very long. Distance between liquid molecule is less, and distance between two solid molecule is again less. This is the third case for solids. The second case is for liquids, and the first case is for gases. Okay. Now here guys, the liquid is there, and when there is a shrinkage of liquid, then what happen? It will convert into the solid, but definitely the distance between the two molecules is going to reduce. Here the number of molecules is trying to come, the distance between the number of molecules are going to reduce. Then this outer molecule, you can see the shrinkage is going to happen, means when the liquid is converting into solid, and you can observe that here the shrinkage is, you can observe the shrinkage is going to happen. The shrinkage is going to happen here. You can see the shrinkage is going to happen, and you can observe here the new boundaries. Yes, you can observe here the new boundaries you can observe. Now this is the casted component. By using that pattern, now we got one casted component here. You can see this is the casted component. This is the casted component, you can see. This is the casted component. Okay. Now guys, what happened here? Now this, I want this casted component and I want the pattern size, then what to do? We need to add the dimension on external side, and we need to add the dimension from external. Means what? We can take some example. Pattern size is equal to pattern size. The pattern size we have to calculate, and we have the two cases, outer diameter and inner diameter. Then pattern size we have to calculate. Then for the pattern size, if we have to calculate the outer diameter if we have to calculate, then what we can take? Outer casting diameter plus allowance, and inner diameter is equal to this is inner casting diameter minus of allowance. This is the inner casting diameter minus of allowance, means this inner diameter of pattern I will get. Understood? Means from the casting size add it to external dimension and reduce from internal dimension. Yes, adding external dimension and subtracting from internal dimension. Means some company will give you order, they want the casting of this size. This is casted component size they will give. Then how you can add the allowance? At the outer side of casting, outer casting diameter you will add the allowance, and from the inner casting size you will reduce the allowance and you will get pattern size. Then adding external dimension and subtracting from internal dimension. Just see, if the casting internal dimension is 10 centimeter, then instead of 10, just some small value we will take 9 centimeter or 8 centimeter. Is subtracting from inner or internal dimension. Okay. Now see the next question. Hot tears are the result of which of the following? Guys, why the hot tears is going to happen? Just see, I come with one diagram, and that diagram is given in P. Raw book. I taken this diagram from the P. Raw book, volume 1. Just see here, this is one of the core, you can see that this is one of the core, and here everywhere we are pouring the molten metal, we are pouring the molten metal, we are pouring the molten metal. Now we are pouring the molten metal here, then here you can see that the thin part of casting, and here you can see the thick part of casting. Then the thin part of casting means which part will convert into solid first. Guys, the thin part has less amount of heat, means less amount of energy. The thick part has more amount of heat, that is the more amount of energy. Then from the thin part you can see the heat is going to transfer, and firstly this thin part is converting into solid. Firstly the thin part is converting into solid, and after then the thick part will start converting into solid. Means thin part will convert into solid, and after then the thick part is started converting into solid. When the thick part is started converting into solid, then because of shrinkage one gap is going to form between the thin part and thick part, and that gap is known as hot crack. That gap is known as hot crack, and therefore restraint of contraction is the correct answer. Yes, lower permeability is wrong answer, lower green strength, more fins. Hot tears are the result of which of the following hot tears is going to happen because of contraction. Contraction means shrinkage is going to happen. The molten metal is converting into solid, and shrinkage means the contraction is going to happen, and therefore we can get this hot tear defect. And guys, this hot tear is also known as hot crack. Hot crack. Hot tear is also known as hot crack. Yes, see the next question now. The process of pouring molten metal in the cavity of metallic mold by gravity is known as. The process of pouring molten metal in the cavity of metallic mold by gravity means, guys, there is one mold. There are two type of mold. One is sand mold, one is metal mold, and in that mold we have to pour the molten metal. But here they said that in the metallic mold we have to pour the molten metal. Then it is known as. Guys, in the die casting we are using the metal mold, and permanent mold casting means also, permanent mold casting means metal mold only. But the die casting has two types. One is gravity die casting and second is pressure die casting. Means by gravity, means in the gravity die casting we are pouring the molten metal simply, directly we are pouring, and molten metal is entering the cavity because of gravitation force. But the die casting has other type also, that is the gravity die casting and pressure die casting. Means in the pressure die casting we are giving the molten metal with some pressure, and therefore we are not writing the die casting as a correct answer, because if I am writing the die casting, that it includes the gravity as well as pressure die casting. Means it includes the gravity die casting as well as pressure die casting. Now permanent mold casting, yes, in all other methods of casting where the mold is permanent, we can pour the molten metal directly by the effect of gravity. Yes, if the permanent mold casting is not an option, then also we can go with the die casting also. Okay, and what is the shell molding here? In the shell molding, we are using the phenolic resin and the sand, that mixture we are going to use, and therefore we are not using the metallic mold there. And pressed casting is just they given the name of pressed casting, but here the correct answer, metallic mold, means permanent mold or the metallic mold, and correct answer is option D. The binder in case of synthetic sand used for molding is. Guys, what is mean by synthetic sand first? Guys, synthetic sand means the sand which we are taking from the lake. Is, guys, the two type of sand. One sand we can take from the river also, the one sand we can take the lake also, and the synthetic sand means the sand which we are taking from the lake, and in that sand there is a very little percentage of clay. What is the clay here? The clay is the added clay and water we need to make the mold. means for making the mold we are using the silica sand. For making the mold we are using silica sand plus clay plus of water. Okay. Then the binder in case of synthetic sand, the binder in case of synthetic sand used for molding is, the binder is what? Bentonite and water. The binder means which bind the number of sand particle, which bind means it is joining the number of sand particle and the joint has good strength. Okay. Then bentonite is one type of clay. There are two type of clay guys. One clay is kaolinite and one is bentonite. Kaolinite and bentonite. Then out of that the bentonite is most commonly used and water also we are using as a binder. To improve the surface finish of casting, the following additives is used in the molding sand. To improve the surface finish of casting, the following additives is used in the molding sand. Guys, while making the mold, if you are using the sea coal in the powder form, this coal is in the powder form and it is very smooth. If you are using this coal, then the mold wall are also very smooth, and in that mold wall means in that cavity we are pouring the molten metal, then we can get the good surface finish of the casting. Means the casted component we can get with the good surface finish. Next, cereals are added in the molding sand. What is mean by cereals are added to the molding sand to improve the following? Guys, in the molding sand we are adding some wheat powder, we can add the corn powder. Okay, these are the cereals, and that wheat powder or corn powder we are going to add to improve the following, to improve the green strength, to improve the green strength. Now, what is mean by green strength? The green strength means what's plasticity. Means while making the mold we can give the good shape to the mold. You know the wheat powder, how the wheat powder, in that wheat powder we are going to add the water and then we are making the chapatis. Okay, then that when we are adding the water into that powder, then it is very flexible, it is very flexible. The same concept also we can use, and that strength is known as green strength. Means in the molding sand we are adding some water also, we are adding wheat powder, then it can give the good plasticity. Then cereals are added to the molding sand to improve the green strength. Non-uniform ramming of molding sand may lead to the following casting defect. Non-uniform ramming. Non-uniform ramming means what? That we need to discuss first. Yes. Guys, the non-uniform ramming means yes. This is the ramming. Ramming means we are giving the force. This is the pattern here, and here you can see the total sand. Yes, here we are adding the force. This is known as ramming, or also we can say the compression. Then if it is a non-uniform ramming of molding sand may lead to the following casting defect. If it is non-uniform ramming, then we can get the scab as the defect, scab as the casting defect. Now, what is the scab? I think you know what is the scab as a casting defect, but I will show you here. see, the scab means what? If we are pouring the molten metal here just see we are pouring the molten metal, then that molten metal is also going here. This is known as scab defect. Means some molten metal is also entering into the sand, and this is known as scab defect. And when we are breaking the mold, then here some impression you can see it here, some extended portion you can see it here, and in that, this is the casted component, guys, and in that you can see some sand particles also you can see, and it is known as scab defect. Next, the hot chamber die casting method is used to cast. Guys, the hot chamber die casting means what? Hot chamber means, I want to speak about the hot mold. Hot chamber means what? Hot chamber means it is one of the hot mold. How we can get the hot mold? We can take the mold, we can put that mold into the furnace, and we can give the heat, and in that hot mold or heated mold we can put some powder, some metal powder. Then that metal powder will extract the heat from the mold, and it will convert into the liquid, and it will take the shape of cavity, and after cooling again it will convert into the solid. Then by using ejector pins we can take out that casted component. It is known as hot chamber die casting. Guys, then that hot chamber die casting is best for lead, tin and zinc. It is best for lead, tin and zinc. It is best for lead, tin, zinc. Okay, lead, tin, zinc. Now see, why it is not useful for aluminum? Guys, the aluminum has more melting point temperature as compared to lead, tin and zinc. Aluminum has more temperature, it is 660 degrees centigrade, but that lead, tin, zinc has a temperature is lesser than 660 degrees centigrade. If in the hot chamber means hot die we are putting the aluminum powder, then it is very difficult for aluminum powder to convert into the molten metal, because what are the heat available in the die that aluminum powder will extract, but that heat is not enough to convert that aluminum powder into the molten metal, and therefore the hot chamber die casting is used for lead, tin and zinc. Here also we can add the cadmium, lead, tin, zinc, cadmium also we can add here. And there is other type, cold chamber die casting. Cold chamber means that mold is cold, and in that cold mold we are directly pouring the molten metal, and in that we can go with the lead, tin, zinc, cadmium, aluminum, magnesium and copper based alloys also. Okay. Next, foundry crucible is made up of. Foundry crucible means, guys, always we are telling that we are pouring the molten metal, but what device we are using to pour the molten metal? Means in which device we are collecting that molten metal? There is one jug, there is one mug, in that we are collecting the molten metal, and that is made by graphite. Then it is known as foundry crucible, and that foundry crucible is made of graphite. Okay, it is known as ladle. One ladle is there, and in that ladle we are pouring and that ladle is made up of graphite material, and in that ladle we are putting the molten metal, and from the ladle we are pouring the molten metal into the casting cavity. Next, chaplets are used in very simple question in last exam, that is SSC JE 2020. You can see here the chaplets are used in very easy, that chaplets are used in casting method. Okay, in the casting we are using chaplets, not in welding, extrusion or not in forging. Okay, here we completed the some or typical question of casting. Now go with the welding. Yes, in helium arc welding, guys, the helium is what? Guys, there are two type of inert gases we can use here. One is argon and one is helium. But guys, almost or in all the welding we are using mixture of this, argon plus helium, Then in helium arc welding the electrode is made of, in helium arc welding the electrode is made of in tungsten. We are using here in TIG method, tungsten inert gas welding we are using the mixture of argon and helium, and in the tungsten inert gas welding we are using the tungsten as electrode. Here the copper, carbon, mild steel is not correct answer. The correct answer is tungsten. In the resistance welding, the pressure is released. Guys, just see the diagram of resistance welding first. Guys, in the resistance welding, we are joining the thin sheets. Now, the sheet number 1 and sheet number 2 we have to join. To join the both sheet, you can observe that we are giving very high pressure with the help of electrode. We are giving very high pressure with the help of electrode. Okay, when now see we are giving very high pressure, then AC power supply we are giving, then here one nugget is going to form. Nugget means what? Nugget means small pool of molten metal. Nugget, this is known as nugget. And what is meaning of nugget? What is meant by nugget? The guys, nugget means it is the small pool of molten metal. Guys, the small pool of molten metal is formed. Means again I am repeating the process. Firstly, take the two sheets, then the both electrode will give very high force on the sheet. Just consider that this hand is one sheet and this hand is second sheet. Put the two sheet like that, and the both electrode will give very high force on the sheets. Then whatever the air present between the two sheets will be squeezed out, means will go out. Then give the AC power supply. If AC is not available, then we can go with the DC also. When the power supply is given, some resistance is developed at the joint, and because of resistance heat is going to generate, and here we got the some small pool of molten metal which is called as nugget. When we got the small pool of molten metal, then immediately we are not removing the force by electrode. If the immediately we are removing, then the joint will not form. Then guys, we have to wait for some time. If you are going to wait for some time, means when this liquid is converting into solid, then we can remove. Yes, now see here, in resistance welding the pressure is released just at the time of passing the current. No, firstly we are going to pass the current, then it will convert into the liquid here. Then when the liquid is converting into solid, then we are removing or we are reducing or relieving the pressure. After completion of current, wrong. After the weld cools, correct. After the weld cools, means when the weld is cooling, means liquid is converting into solid, then we are going to remove that. Okay. Then here also you can see the diagram, here the welding time, and here you can see that the weld is completed, but here you can see that the liquid is there. This is nugget, liquid is there, but here you can see that the liquid is converting into solid. When it is converting into solid, then we can remove the force. You can observe that this diagram, on the x-axis there is time, on the y-axis there is a force. First there is squeeze time. Squeeze time means the electrode is giving force on both the sheets, and that time is known as squeeze time. And this is the weld time, and here you can see that here we got the liquid, and when that liquid is converting into solid, then you can see that the force is removed, means the electrode we removed. Hence here the correct answer after the weld cools. Next, material used for coating the electrode is called as. Guys, on the electrode we are giving one coating, and that coating is known as flux coating. That coating is known as flux coating. But what is meant by slag here? Guys, the molten flux is known as slag. Molten flux is known as slag. The molten flux is known as slag. Means when the flux is melting, then we got the slag. Then, but the material used for coating the electrode, there are two type of electrode in old welding. One is coated electrode and second is bare wire electrode. Bare wire electrode means no coating on the electrode, and coated electrode means the flux coating we are giving on the electrode. Next, in which type of welding is the pool of molten metal is used? Pool means large pool of molten metal. Okay, in which method of arc welding the large pool of molten metal? Large pool of molten metal means large liquid metal we can observe. Guys, out of that TIG, MIG, submerged arc welding, electroslag welding, the thickest plate we can join in electroslag welding. You see, the thickness of plate is more than 75 millimeters, 75, 80, 90, 100, 110, 120 millimeter means big or more thickness plate if we have to join, then because of more thickness the pool of molten metal means liquid molten metal formed is big, hence the big pool of molten metal is formed in electroslag welding. But here in that question you can see that in which type of welding the pool of molten metal is used, means large pool of. In all the method we can get somewhat here the smallest pool of molten metal in the TIG, somewhat bigger in MIG, again bigger in submerged arc welding, and biggest pool of molten metal we can obtain in electroslag welding. For arc heating, the electrode are made up of arc heating. Arc heating means if we are using the arc welding, then which type of electrode we can use? The graphite electrode we can use. Guys, the graphite has very high melting point temperature around 3600 degrees centigrade. Instead of graphite here, that they given the tungsten, then we can go with the answer tungsten. Instead of graphite here they written the carbon, then we can go with the carbon as answer, because the carbon, graphite, tungsten, all three has a melting point temperature is very high, which is greater than 3000 degree centigrade, which is greater than 3000 degree centigrade. Okay. Then copper, aluminium, ACSR conductor. Guys, do you know what is ACSR? A stand for what? Aluminium. Aluminium conductor, steel reinforced. Means aluminium electrode is there. Aluminium conductor means aluminium electrode is there and the steel is reinforced in that, means some steel is also kept in that electrode. But the graphite is the correct answer. The phenomena of weld decay occurs in, guys, what is meant by weld decay? Means, guys, in the welding some corrosion is going to occur. Or also we can say the intergranular corrosion occurring in the stainless steel is known as weld decay. Then the phenomena of weld decay occurs in stainless steel, means intergranular corrosion is going to occur in the stainless steel. Okay. Then weld decay occurs in the stainless steel. Next, solder is essentially, guys, solder means what? In the soldering method, the filler rod we are using, and that filler rod is known as what? Solder. And that solder is made by lead tin alloy, means lead 50%, tin 50% we can use, and that mixture, that alloy we can use at solder in the soldering method, means filler rod used in soldering method is known as solder. Filler rod used in soldering method is known as solder. Next, which of the following is an example of semi-automatic welding process? Guys, why I taken this question? Guys, the four famous method is there. One is TIG, second is MIG, third is SAW, that is submerged arc welding, and here one just we discussed electroslag welding. The four famous methods are there. Out of that, what happened is TIG welding is the manual welding. Means one welder is going there and welder is working. Means electrodes the welder is holding in one of hand and the filler rod is holding in other hand like that. Now you can see this pen as the filler rod, and this is the electrode he is holding like that, and he is doing the welding. You can see that, and he is doing the welding. This is filler rod, this is electrode in the TIG. Means TIG is not a semi-automatic, it is the manual welding process. The TIG is manual welding. But in, guys, MIG and SAW, in both method we are using some automation. But fully automation is not there. Full automation is not there. If the full automation is there, then we can say the MIG and submerged arc welding are automatic methods. But here you can see that which of the following is the example of semi-automatic welding process. The correct answer, the both options are there. Option B as well as option C is the correct answer. The both method. Guys, in both method is not a fully automatic because the machine will work automatically. If the two plates are there which we have to weld, here we have to do the welding, then the process will start from here and it will go up to the end. Automatically, the machine will work automatically. But guys, firstly the position of electrode we need to set, means one human being is there, one person is there, one welder is there who is setting the two plates as well as the position of electrode he is setting, and the electrode is moving slowly and welding is going to complete. Then initially some welder is required, hence it is not fully automatic, it is the semi-automatic. Hence the both options are correct here. The both methods are the example of semi-automatic, and this is resistance is different welding. First three are the arc welding and resistance welding is the resistance welding. Filler metal is used in. Guys, what is meant by filler metal? Filler metal also we can say as a filler rod. Filler metal means what? The filler metal means it is the filler rod. Filler rod means what? When the welding is going on, if we require some extra molten metal, then that filler rod is supplying the extra molten metal. Then the gas welding we require that extra molten metal, hence the filler rod. Filler metal or filler rod used in gas welding is the correct answer. Okay. Then projection welding, seam welding, spot welding, all are the resistance welding where filler rod is not required. Only the filler rod is required in the gas welding here. In arc welding, the arc length should be approximately equal to. Now I will show you one diagram in the arc welding. Guys, there is one long slender rod is there, and here we have to join the two plates. Guys, that rod has some diameter. This rod has some diameter. Then the small d is the diameter of rod, and this is the tip of electrode, and this is the distance between the tip of electrode and the plate is known as capital L. Then what is that capital L here? Capital is arc length and small d is what? Diameter of wire. Diameter of wire, and this is the wire, or that wire we can also say as electrode. Diameter of wire or electrode we can say. Then guys, there is one relation. The diameter of wire or electrode is approximately equal to capital L arc length. Now what is meaning by arc length? What is meaning by arc length? Arc length means distance between this welding plate and the tip of electrode is known as arc length. Then diameter is approximately equal to arc length, then is this option available here? Yes, option is available, and that correct option is option D. In arc welding, the arc length should be approximately equal to diameter of electrode. Arc length should be approximately equal to diameter of electrode. Okay. Now see next question. In a thermite welding, the aluminum and iron oxide are mixed in the proportion of. Guys, thermite welding is one of the chemical welding process which is exothermic. In that we are taking the aluminum powder and iron oxide. We are taking the aluminum as to iron oxide is 1:3. Okay, by weight, we are taking the weight. Here the weight is not written, but in thermite welding the aluminum and iron oxide are mixed in the proportion of 1:3 by weight. Means if the aluminum 1 gram we are taking, then iron oxide we have to take the 3 gram, 1:3. If we are taking the aluminum 2 gram, then we have to take here it is 6 gram, that is the 2:6, means it is 1:3 only, but it is by weight. Therefore, I am using the unit gram. Next, if electric current is passed through the metals to be joined and heated the plastic state, and weld is completed by the application of pressure. Guys, the resistance welding is the pressure welding method. In one diagram, we discussed that in the resistance welding, the electrode is giving force on the welding plate. Then here the correct answer is resistance welding. Okay. In the resistance welding, we are supplying the electric current through the metal to be joined, means in the two sheets we have to join, and in the resistance welding from the two sheets only we are supplying the current, and it is heated to plastic state, and weld is completed by the application of pressure. The welding is known as resistance welding. The welding is known as resistance welding. Okay. Next, which of the following is an example of solid state welding? Which of the following is the example of solid state welding? Yes, what is mean by solid state welding? If we are discussing the gas welding, then the solid metal is converting into the liquid metal. The arc welding is also same. In the thermite welding also the solid metal is converting into the liquid metal, and these all three are not a solid state welding, these all three are fusion welding. These all three are fusion welding. But guys, the forge welding is very old method which is not a fusion welding, it is simply known as solid state welding. What is mean by solid state welding? Guys, here is one rod and I want to join the second rod to here. Then we are giving the heat to the first rod, second rod we are giving the heat, and on that we are giving the force by hammer. Here we are giving the force by hammer, then this will join, and this is known as what? Forge welding. This is one of the oldest welding method, and it is solid state welding, means it is not converting into the liquid, it is in solid only. Here no part of both rod is converting into liquid. The strength of a property welding joint as compared to base metal, just see the two plates we want to join here. Guys, at the joint, what will be the strength? This is the plate, and this is the joint, where the strength must be more. Guys, most of the time what happen at the joint, the strength will be the less, but it must not happen. At the joint, means here, the strength, and at the plate, the strength must be same. The strength must be same or strength must be more. Means at the joint, the strength must be same as the plate, or at the joint, the strength must be more than the plate. The both answer, that is option A as well as option B, is right. Okay. Yes, now here the welding question we completed, welding concept we completed, and the two important topics are there. The casting and welding is very important topics. Both topics are very important. The number of questions are asked in previous year SSC exam as well as other exam. Now see the next topic, NTM, that is non-traditional machining method. Now guys, in the non-traditional machining method, you can see one of the machine is ultrasonic machining method. Guys, in the ultrasonic machining method, we are making the hole in brittle workpieces. And to make the holes in the brittle workpieces, we are using the tool is very soft tool, means brass or copper tool we can use. Means guys, in the ultrasonic machining method, the mechanism of material removal is brittle manufacturing. Mechanism of material removal is brittle manufacturing. Mechanism of material removal is what? Brittle manufacturing is the mechanism. Brittle manufacturing means brittle material is going to cut. Okay. Then The brittle workpieces we can machine, brittle material we can cut. Then if the tool is also made by brittle material, then there is some material removal of the tool also. Therefore, the tool is always made by soft materials such like brass or copper. Then tool in the case of ultrasonic machining is made of brass or copper. If you are using HSS, diamond and stainless steel, then there is also some brittle manufacturing will be there, or we can use the mechanism of material removal is because of brittleness. Okay. Here I am going to cut the manufacturing word, not manufacturing, because of brittleness it is going to cut. Okay. Now see next, in the electro discharge machining process, idiom. In the electro discharge machining process, the workpiece and the electrode are submerged in. Guys, in the idiom method, we are using the kerosene, means dielectric medium, dielectric fluid such like a kerosene we are using. Dielectric means what? The electricity is not traveling through that fluid is known as dielectric fluid, and that dielectric fluid we are going to use in idiom method. Okay. Now see some question of metrology now. The metrology is very big chapter, but for the SSC very less questions are asked on metrology, but in the next exam metrology is very big topic, they can ask the number of questions also. The crank pin is to be connected in the bush, means there is one bush and in that bush we have to fit that crank pin. And the dimension of bush and crank, you can see that these are the dimension of bush and these are the dimensions of crank. Means for the bush the upper limit and lower limit is given, and from the crank also the upper limit and lower limit is given. The maximum clearance between the bush and crank pin is maximum clearance we have to calculate. Maximum clearance. Okay. Then maximum clearance means what? We can take the maximum limit on the bush. This is for the bush. This is for a crank. Then maximum limit on the bush, you can see that it is 16.017 minus of minimum limit. Here the minimum limit, you can see that is minimum limit is 16 minus 0.062. This is minimum limit. Then we can get the maximum clearance. Maximum clearance means maximum difference between that. If you are going to calculate, you will get the correct option as option A, 0.079 millimeter. Okay. Very easy. If you learn the metrology, then very easily you can give the answer. Next, the crest diameter of screw thread is same as, just see this, I am showing you the diagram of screw thread here. Here in the screw thread you can see that this is the major diameter. I am showing the major diameter as capital M. This is the minor diameter as the small m. Then the crest diameter of screw thread. The crest diameter of screw thread is same as major diameter. This is the capital M. This is the crest diameter of screw thread is same as major diameter. Okay. Yes. Now here all the questions are completed, and here is one announcement. Here you can see that. Yes. You can see here we have one mega mock test. On the date you can see the 26th May 2024 you have one mock test. That test is very important. It will give the experience of your SSC prelim exam. Same type of questions are made here, which can give very good experience before your SSC prelim exam. Then this mega mock test is very important for you. This is in online mode and it is available for civil engineering, mechanical engineering and electrical engineering. 26th May, please remember the date, 1 p.m. to 3 p.m. Okay, understood? This is very best announcement for you SSC JE 2024. Okay. And finally, I want to say you thank you for watching this lecture. I hope so. This lecture is very beneficial for you for some questions, some typical question I taken here, which may create the confusion for the student, and I hope so I cleared that doubts, that question in this session. And thank you again for watching this lecture, and all the best for your exam.